Welcome to week 3. This week is all about problem solving. Textbook chapter 3, starting on page 46, covers problem solving. Your textbook defines problem solving as the isolation and analysis of a problem and the development of a permanent solution. Those of you who are in the Industrial Engineering Technology program will be paid to solve problems. It'll be part of your daily work. You're going to be problem solvers and decision makers. You should use a systematic problem solving approach to problem solving. What you should not do is hear that there is a problem and then try some quick trial and error methods to solve it. You should adopt the correct problem solving methodology for the problem that you experience and then follow it. 2 problem solving methodologies the book talks about are Plan, Do, Study, Act cycle of DeMike and the DeMike model that's used with the Six Sigma methodology. If you go to page 48 in your textbook, there's a figure 3.1, who outlines the Plan, Do, Study, Act cycle. You can see that in the planning phase of a problem or a project, you would first recognize a problem exists. That could be done by operators alerting you, or maybe some data that you saw, some weekly or monthly data. For example, the scrap report says, oh, we have 20% scrap on such and such product line. So you know there's a problem. You would form an improvement team. You would develop performance measures. Maybe you say, okay, we want to reduce the scrap by 10%. You would clearly define the problem, document and analyze the process that's associated with the problem, so flow chart and so on and so forth, and determine possible causes. All that would be done in the plan phase. In the do phase, you would identify, select and implement solution. Now you can see, if you look at the DeMike cycle, that more than half the cycle is eaten up by the planning phase. That also is associated with the time that you should spend in this phase to really figure out what truly is your problem. Albert Einstein was once asked if the world would be in imminent danger and he would have only 1 hour to solve this problem, how would he spend his time? And Albert Einstein said he would spend 55 minutes on trying to identify what the problem is and only 5 minutes on the solution. Now think about that. All too often we spend 1 minute on trying to figure out what the problem is and 59 minutes on trying to figure out a solution. So really the message here is spend an adequate amount of time in trying to figure out what is my problem really, and then the solution will present itself. So the planning phase takes up most of the time in the problem solving methodology. Then comes the do phase, which means we have to identify, select and implement a solution. You can see that takes up relatively little time. Then in the study phase, you would evaluate solution. Sometimes this phase is also called the check phase. And there's certain tools that go with this, and they are outlined in your book there. Control charts, run charts, scatter diagrams and so on and so forth are some tools that you would typically use in this phase. And then comes the act phase, where you make sure that whatever solution you had put in place will be in place permanently. So that's when you would write standard operating procedures, train your employees and so on and so forth. So that's the DeMike cycle, also sometimes called the Shewhart cycle. Then the second problem solving methodology your book talks about is the DeMike model, following the Six Sigma methodology. DeMike stands for Define, Measure, Analyze, Improve and Control. On page 49 in your book, the DeMike model is contrasted to the Plan, Do, Study, Act cycle, and you can see the steps involved within each problem solving methodology and then what you would do in each phase. Now in the define phase, you would typically identify your improvement opportunity. This means you would develop your problem statement, you would figure out what the opportunity is, like how much money could we save doing this project. You would set some goals. For example, we want to improve the process by 10%, or you want to improve the lead time by so many days. You would get your team together, figure out who's on your team, scope out your project, like what will you address, what will you not address, and set a timeline. Once you have achieved that, you would move to the measure phase, where you collect data to describe the current process. So you would look at performance measures that describe your problem, and then collect data on all of them. This phase is if you have to measure things. For example, if your project has to do with dimensions, for example, maybe you have a problem with the diameter of a problem, and you would measure the diameter with calipers. So one of the things you would do is also make sure your measurement system is adequate. You would check the bias, and you would check the variation in your measurement system. That's called measurement systems analysis. We'll cover that towards the end of the semester. Once you have collected your data, you move into the analyze phase. That's where you study the data. The analyze phase is all about figuring out the root cause of your problem. So all your data analysis should lead you to what the root cause is of your problem. Once you have the root cause identified, you can start looking for a solution. That will take place in the improvement phase. In the improvement phase, you will find the solution to your problem. And then in the control phase, you kind of study, or you kind of see if the solution that you have implemented really works. So you monitor your process, and you also put in place any standard operating procedures that may have changed, train your operators, make sure that the solution can be permanent. On page 49, as I said, you can see a comparison of the DeMike model and the Plan, Do, Study, Act cycle. On page 50, you can see the Plan, Do, Study, Act cycle with the respective tools. So for example, in the first row, in the planning phase, you may recognize a problem or issue exists. The tools that you may use for that are surveys, run charts, breeder charts, histograms, check sheets, audits, or focus groups. So from those tools you take off the information. It makes it nice to have a structured problem-solving approach, because it can lead you through your process from step 1, and it also tells you what tools to use. So I encourage you to really pay close attention to the text in chapter 3, because what's described in chapter 3 you will use on a daily basis when you go to work. Now on page 51, on the bottom right, step 3 in Plan, it talks about developing performance measures. I want to talk into more detail in this chapter about the voice of the customer, and then how you can translate that voice of the customer into something measurable called a metric or a performance measure or a critical to quality characteristics. Basically, as a company, a business, or an organization, we have to know at the end of the month how we did, how we satisfied our customers' requirements. And the best way to do that is to develop measures of performance, and then collect data on that, and then look at that data and see how we did. So measures provide information in a way that compares performance against the requirement. It compares what's happening to what should be happening. Those measures can be financial, customer-oriented, they can be really anything. And we are going to give you some examples in a minute here. On page 53 in your book, figure 3-6 gives you some examples of measures of performance, things that we as an organization can keep track of to see how we are doing, how we are satisfying customers. So in that figure 3-6, you can see number of repeat customers could be a measure of performance. Service time, how long does it take to do something? How long does it take to deliver a pizza, for example? Or how long does it take to check in patients into a hospital? Number of sales, number of returned product, count of reasons for return, number of deviations from product service specifications, number of incorrect procedures, and so on and so forth. What do all those measures of performance have in common? they have some sort of a unit. It's either amounts, or it's number of, or it's percentage. On the slide here you can all see some examples of financial measures like cost, return on investment, customer-oriented measures example like response time, delivery times, and so on and so forth. Let's do an exercise. Go to your book, page 94, problem 18, no, page 96. Go to your book, page 96, and look at problem 18. Now that will refer you to problem 6, which is on page 94. It asks you to read that problem on page 94. Problem 6. A pizza company with stores located citywide uses one order call-in phone number, blah 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 blah. And then you need to develop 2 measures of performance that can be used to determine if the changes that were made were effective. So I'm going to stop this presentation right here. That gives you time to go read that case on page 94, and then you will have to develop 2 performance measures. See if you can do that. And then after you have done that, continue to listen to section 3-2.